Part G. What position number is the 100th green block? Explain your answer. So we're not dealing with this list anymore, we're dealing with these lists here separately. So we're asked about at the position of the 100th green block. So we're dealing with green blocks, so I'm going to write that down because I've got two lists I need to worry about, and I know I'm dealing with this list here. So I want to know the 100th green block. So I'm dealing with my terms. What's the 100th term in this list? Well, we can probably figure it out, but I'm going to write it out as logically as I can. I know that my first term is 2. I know that my second term is 4. I know that my 10th term is 20. Well, what am I doing each time? If I have term number 1, it's 2. If I have term number 2, it's 4. If I have term number 10, it's 20. Well, it's like I'm multiplying by 2. Whatever my term is, I multiply it by 2. And I end up getting the block. So I have 2 by 10 for my term is going to be 20. Let's test if that idea works. So I have 2 by 1 here. Let's check if this works for the 5th term. So T5 would be 2 by 5 would equal 10. And does that work out? Yep. The 5th term is 10. So this is the pattern that I'm seeing here in my numbers. So working with that pattern, that would mean that I'd have 2 by 100 would give me 200 for my 100th green block. So that's my argument for part G. And this counts as an explanation. We know in maths that we're telling a story through maths. So this is a perfectly good argument. If I see this on the page in an exam, I think this person has made a very good mathematical argument. So my argument doesn't necessarily need to be in English. If I can show what I'm doing here, that argument is perfectly good. Now, let's see about H. Well, if I look at H, if I look at my lists here, so my first term is 2 in my green list, and my first term is 1 in my red list. My second term is 4 in my green list, and it's 3 in my red list. And I see that this pattern continues all the way up. I'm always, if I have a number in my green list, I'm 1 less it in my red list. So my reds are always 1 less than my greens. So let's see if that works. So for my red list then I'd have, as I said, if I had my third term here, if I take 1 away from that, I end up with my third term in my red list. And for any of them that I want to try, that works out. So then my way of getting this would be my 100th term in my red list, for my red list, is going to be whatever my 100th term was for my green list minus 1. So I get 199. Now let's have a look at part 3. Gillian said to find the position number of a green block, I just have to work out 2n where n is a natural number. Explain what Gillian meant. Well, if I had this situation here, so I'm back to talking about greens. If I had T1 in my greens list, I figured out that that was 2 by 1, which was 2. If I had T5, I checked that and I said it was 2 by 5 was 10, and that worked out. And if I had T100, that was 2 by 100, and that worked out to 200. I just used that. Well, if I had Tn, would be just some number, can be any number I like, any natural number I like. I can see 1, 5, 100, 15, whatever I like, are all natural numbers. Well, that would be 2 multiplied by whatever n was. And the short way of writing that is 2n. So I'm happy that Gillian has made a good argument. And again, this counts as an argument for what Gillian has said. So we don't need to necessarily give an English argument. We can give a maths argument instead. Now Barry said to find the position number of the red block, you work out 2n minus 1, where n is a natural number. Does this work? Explain what 2n minus 1 means in this context. Well, this is actually basically the argument that we made just here, isn't it? We saw when we looked at our lists that to get a red number, it was 1 minus our green number. So for our T1 in our greens, we had 2. If we take 1 away from that, we get 1, our T1 in our red list. If we had T10 in our green list, that was 20. And if we take away 1 from that, we get our T10 in our red list. So we saw this argument before. We used it for doing part H. So we saw that any red term is equal to our green term minus 1. Well, we just figured out that our green term is 2n. So our red term then is going to be our green term minus 1, which is what Barry said. So I would be in agreement with Barry in that. So this is what we're doing. You can see that we're starting to get letters involved here, and the letters are going to be very important for our patterns moving forward. But we can see how we can build up an argument from writing our list out carefully and then seeing what patterns we can spot. We can build up to where we start to make arguments involving letters, which is where we want to be going. And that's what we need for now.